Hello. Hello. So in this video, I'm going to discuss about the interfacing of LCD with 8051. So in order to understand the interfacing, we need to first understand the basic of a LCD. So you know what is the full form of LCD is nothing but liquid crystal display. So generally, it is available in different form. The forms 16:1. This one of the form where the 16 columns will be there, or 16 characters actually. You can put like this way, where one single line will be there, a single row will be there, and column wise 16 character you can put. Okay. This is one of the category. Another category 16:2, where two lines will be there. So you can display the characters in two lines, and each of the line is having 16 characters. Maximum you can display, or you can go 20 cross 4 also. You can go for this one also, 20 cross 4. So here actually 4 rows will be there for the display purpose, and each of the row will have maximum 16 character 20 characters. Sorry. Okay. So in this video, we'll be discussing about 16 cross 2. Generally in interfacing, this type of LCD generally used in most of the cases. Now, what are the things are available in actually in this particular type of LCD? So in a very simple way, if you want to understand the LCD, what are the pins are actually available? The pins are RS, RW, and E. These are the most important pins of LCD, and these are known as control lines also. These you can call as control lines also. These are used for the controlling purpose. Control lines. Okay. Now, what is RS? RS stands for register select. Okay. So actually in LCD, two registers are there. One is command register. Another one is data register. So if you want to do some data operation by using 8051, you have to use this data register of LCD. And if you want to do some command operation, then you have to use this command register. Okay. So how to select a particular register out of these two, how to select a particular one. So if you put RS equal to 0, it means it selects command register. Whereas if you give RS equal to 1, it selects data register. So if you want to do data operation, then you need to put RS equal to 1. And if you want to do command, if you want to use some command operation, then you have to use RS equal to 0 to select the command register. Now, what about the RW? RW is nothing but read rate. So if you want to read something from the LCD, then you have to make RW this particular thing. If you want to read something, you need to make it 1. It means read data from LCD. Means 8051 will read some data from LCD. Now, if you want to write some data in the LCD, then you need to make RWS 0. So if you make RWS 0, write data into the LCD. Okay. And what about the third one? Third one is enable. So this enable. So whenever you are trying to use LCD, means you are interfacing LCD with 8051 and you want to do some data operation or command operation. If you give some command operation or data operation, then you need to make this enable as 1 to 0 transition. 1 to 0 transition means you need to first make this particular E as 1 and you need to make it 1 for some time. So how to make it 1 for some time? You can do some delay operation. Okay, and after that, after a particular time delay interval, you need to make it 0. So you need to do the transition from 1 to 0 in order to do some data or command operation in LCD. You need to make this E as initially it has to be 1 and after some time delay it has to be 0. Then only these operations will be done. Okay, so these are the main three control lines. Other than that, let me draw here also. It has a data line from D0 to D7. This bidirectional. It can take or it can transfer. Okay, so this bidirectional D0 to D7. It has 8 data lines. 8 data lines. So when you want to do some data transfer from 8051 to LCD, you can do it by using these data lines D0 to D7. So D0 to D7, these are data lines. Okay, and other than that, you have means it has other three terminals like VCC. It has to give is VCC terminal. So in VCC terminal, you have to give plus 5 volt. It has one VCC terminal. It has one ground terminal, which is known as VSS. So it has to be connected to 0 volt or you have to connect it to ground. And in between that, you have one variable resistor or which is known as potentiometer of 10 kilo ohm. So and this is connected to one terminal which is known as VEE. So why this is used? This is used to change the brightness of the LCD. Okay, so as you are using a potentiometer here, means it is a variable resistor. By changing the value of this resistance, you can change the brightness of the LCD. So for programming purpose, these terminals will not be considered. We'll be mainly focusing on these three terminals for the control operation. Means these three things will be there for the controlling purpose, or for the command operation generally we'll be using these three, and in fact for data operation also we need to use enable. So these three control lines will be used in a generalized way. If I want to say, then these three control lines will be used along with this D0 to D7 data lines for the programming purpose. We need to focus on these particular pins. Okay, now in LCD, if you want to understand some interfacing of LCD with 8051, you have to understand the different initialization commands. Initialization commands of LCD. So basically, you need to remember some values which will be indicating some particular thing. For example, if we tell if you consider this 38 value, 38 hexadecimal value, it represents two-line display. So when I'll show a program to do the interfacing of LCD with 8051, this thing will be more clear to you. So for the timing, you try to remember these points. 38H, it represents two-line display. So if you want to use a LCD with these two lines, because initially I told that we'll be focusing on 16x2. If you want to use both the lines, then you need to give this 38H to a particular port. This value you need to give to a particular port, and some command instruction you need to, or some command operation you need to use. Okay, so this represent 38H represent two-line display. And two-line display means you can use two rows for the display purpose, and each of the character in each of the row. Okay, because 16 columns will be there and two rows will be there, and each of the character will be represented by 5x7 dots. Okay, each of the character, okay, will be represented by 5x7 dots, means 5 columns will be there in each of the position. 5 columns will be there, or this type of section will be there, and 7 rows will be there to represent each of the dot. Means each of the position is having this type of thing, 5x7 dot, and this is applicable for each of the position. Okay, this is the meaning of 5x7 dot. Okay, now other than that, this OE is also very important. It means display on as well as cursor. Means when you are displaying, some cursor will be there on the display. Cursor will also be remain on if you give OEH. Okay. Now, if you want to clear the display, at that time you need to give 0 or 1 hexadecimal value. This means it clears the display. Okay. Now, if you want to force your cursor to come to the first position, then you have to give this value 80H. 80H will force the cursor during this display operation. Force the cursor to come to first line, to come to first position of first line, actually, to come to first position of first line. Okay, it represents this particular position, this first position of first line. Okay, this particular position, first position of first line. Now, other than that, these are the actually 4 important things that you need to use while doing the interfacing of this 16x2 LCD with 8051. Other than that, this one also you can use for some specific operation 30H. This means that you are using a first line or one line. Okay, for one line, not exactly first line, is for one line. If you want to display in one line, you need to use 30H. Okay, so these are the things you need to remember. Basically, these first 4 things you need to remember. Okay, if you want to do some interfacing with 8051. Now, and what you have to understand other than that. So when you are doing the interfacing, actually 2 things will be there. One, you need to perform command operation, I already told, and you need to do data operation. So in this case, in each of the case, some steps are followed. Okay. So what are the things need to be done in each of the steps? So if you want to do command operation, you need to first clear, or you need to make RW as 0. Why? Because you are sending some command from 8051 to this LCD display. So this is nothing but a write operation you are doing. And there that time command register will be used. Command register from LCD it will be used. So in that case, if you can remember, I already told, if you use your command register, then RS has to be 0. Okay, I'll come to this point, and along with that one, as you are doing the writing operation, you need to make RW equal to 0. So first of all, you make here, if you want to do command operation, you need to make RW equal to 0. And you know how to make it by using some instruction of 8051. You need to do CLR RW. This is very simple way you can do. Now after that, what you can do is you need to make RS equal to 0. Why RS equal to 0? Just few seconds ago I told. As you are doing command operation, you need to use command register, and in that case, you need to make RS equal to 0. Register select, you need to make 0. RS equal to 0. Now how to do? By using instruction, you can write CLR RS. Now after that, what you have to do, I already told, if you want to do some command operation and data operation, in each of the case, you need to use this E or enable bit. You need to make it first 1. You need to hold it for a particular time. You need to give some delay, and after that you need to make it 0. So how to do that? So first of all, how to make it 1 first? So what you need to do? First of all, you need to make E equal to 1, and after some delay, it has to be 0. So how to do that? Set V E. So what does it mean? Set V E means it is making E 1. Then you can do some delay. You can do some delay operation. So you can use a call function, and you can write a separate delay function, delay program or subroutine to do this delay operation. Now you need to make it 0 because 1, then you are having some delay. After that, you need to make it 0. So what you can do? Clear. Okay. So you need to first make it 1, then it has to hold this value for some duration, and then it has to be 0. Then only it will be working. And after that, at the end, what you need to do? You need to come out from this program, and this type of operations you need to use as a subroutine. So you can use return, so that I'll show for the program purpose. When I'll show a program, that time I'll show what you need to do after that. Now, same thing if you want to do for data operation, then what are the things to be followed? So RW, again it has to be 0, and what you need to write? Clear RW, that I already written. Why? Because data operation also means you are transferring some data from 8051 to LCD. So if you want to write something on the LCD, or if you want to display something on the LCD, so you are doing the writing operation. So RW should be 0. Okay. And after that, now as you are doing data operation, if you can remember, your RS register has to be, means RS has to be 1. Why? Because this time, as you are doing data operation, you need to select data register. So if you want to select data register, you need to make RS equal to 1. So make RS equal to 1. And how to make RS equal to 1 is very easy to understand. You need to write set B RS. This is the instruction you need to use. And after that, what you need to do? Same operation what you have done here. E first has to be 1. It has to hold this 1 for some duration, and it has to make 0. And how to do that? Set BE, then a call delay, and then you need to make CLR equal to 0. So these are the steps you need to follow for data operation. So see, the things are almost same in both the cases. Only the difference is here you are making RS equal to 0 because you are doing command operation. Here you need to make RS equal to 1 because you are doing the data operation. So these are the things you need to do if you want to do the programming. Now, how to do the programming. So before coming for the before discussing this program, let me show you one schematic type of thing so that you can easily understand how you need to do this interfacing between 8051 and LCD. So suppose this is your 8051 microcontroller and you have one LCD. So what you need to do, any port of 8051 you can use to send the data in LCD display. So in LCD, you know, D0 to D7 is there for data operation so that you can connect to any port. So for example, we want to use port 2 of 8051 for data operation. So you can write P2 here. OK. And other than that, you know, three control lines are there in LCD. These are RS, RW, and E. So what you can do, RS you can connect to some other port of 8051. For example, we can take port 1, pin number 0 for RS, then for RW port 1, pin number 1, and then for E port 1, pin number 2, we can connect to these three different lines. And after that, we can do the display operation by using some coding technique. OK. So here I will show one assembly language program how to do that, how to do some interfacing with the 8051 with the LCD. So we'll be trying to write two word, one of the word in the first line, second word in the second line to display in the LCD, and the word is suppose VIT scope. Okay, so VIT will write in the first line and scope will write in the second line. Now what program we need to have to do this particular operation? So let me show the program first. This is the program what you need to do. This is very simple to understand. First of all, what we are doing, org00, this is the starting address. Then RSEQU P1.0, because here I shown one example like I want to make some connection between RS and port 1 pin number 0. And EQU doesn't mean that it is making some connection, means in without using P1.0, if you want to use this RS, that also you can use by using RS EQU P1.0. OK, because next time we won't write P1.0, we'll be directly writing RS. And connection you need to do in hardware also, you need to first connect 8051 with LCD, then you can do the you can even dump the program in 8051 and you can display the character whatever you want. So here also this code along with this code also you need to make connection between 8051. You need to do interfacing between 8051 and LCD. Then only it will be possible to show this particular thing whatever we have asked. Okay. Now P1.0 is represented by RS by using EQU. Then P1.1 is represented by RW and P1.2 is represented by E. Okay. Now, you know, I already told if you want to do some interfacing of LCD with 8051, some command operation you need to follow. And some initialization you need to do. And what are the things I have written 38. So you know what is the meaning of 38? It will be a two-line display because we want to write VIT in one line, scope in other line. So two-line display. That's why I've given 32. Then along with that one, we have to do display on as well as cursor also on. When we'll be showing the result at the time, display will be on and the cursor will also be on. I'll be showing the result. So for that I have taken 0E, and this third one this 0, 1. 0, 1 is to clear the display initially. Okay, so these are the three things we have taken, and along with that one, in some loop we will be taking ATH also. Means ATH, what it will do every time your cursor will come to the first position when it is doing the display every time, because this display will be keep on doing iteratively. So and every iteration your cursor should start from the first point only. So that's why in the iteration first line, so this is back is some sort of iteration here. I have written back move p2 comma ATH. So it is in order to make the cursor to come in the first point of the first line every time when the iteration starts. Okay, so these are the commands line, and after every command operation or after every initialization of command, you need to call this command one, and what command one it is, I will tell you. So see, every time move p2 comma hash 38, and I have written a call command 1 and move p2 hash 0eh. Then again I have written here a call comma command 1. So whenever we are doing the command operation, I'm calling this, I'm going to this command 1 portion. And what it is command 1 portion, I already told in the while I was discussing this 8051 LCD display unit, I told that few operations you need to do. You need to do this command operation as well as data operation. So just now we are talking about the command operation. You need to perform these operations, whatever I told. So you see these operations are written only CLR RW, then CLR RS, then set BE to make it one first. Then we are waiting for some delay, a call delay, then CLRE. We are making it 0 again and return to come out from the program from the subroutine to the main program. So these are the steps only we have followed. These are the steps we have followed. Okay. Okay. Now, so this initialization of the command we have done, and every time we need to follow those steps. Means you need to come to this particular subroutine of command 1, and this is the command 1 part. And what inside the command 1 you need to do, I already told. These are the steps. These are the steps you need to follow. Now you come for the data operation. Why data operation? Because I need to transfer VIT scope. Okay, so for that what I have done. So initially what I have done, move P2 ATH and equal command. This is also a command operation. Why I am doing? I already told. I need to make your cursor at the first position of the first line every time while doing this iteration. This back is some sort of level. I'll show here. This is the end of the back level. From here, you need to jump to this back. Okay. Okay, and this is iterative operation because you need to continuously display VAT score, VAT score. Okay, so how to do that? It's a very simple thing. Move P2 because in the example also I've taken this example that P2 I am taking as a port. P2 I have taken as the port to transfer the data from 8051, and that will be collected by your D0 to D7 line of LCD. So that's why I have written port to move P2 comma hash v, because first if you want to transfer VAT, so first you need to transfer v and the corresponding ASCII value will be given to the P2 port. Then as you have done this data operation, because v you are transferring to P2, this is a data transfer operation you have done. So now you need to use this a call data one, and for data operation, what are the steps we need to follow? I already told. These are the steps you need to follow. So I'll show you. See, this is the data operation. This is subroutine. What we are doing, clearing RW, then set BRS, set BE, a call delay, clear E, RED. These are nothing but this operation just now I discussed few minutes before I discuss. These are the things you need to follow. So that's why a separate subroutine is written for the data operation. And before that, I have shown subroutine for the command operation. Okay, now I can come to the main program. What we are doing here, first we have transferred V, then I, then T. Okay, then we need to come to the next line. So if you want to come to the next line, you need to use this uh, value C0. If you use this C0, it means that, and see, this is a command, nothing but this is a command. You see a call command also I have written here. Though, so using this C0, what we are doing, we are coming to the next line. So C0 means C0 is also one of the initialization command. So C0, what it does, C0H, what it does, comes to the second line of the display. So I told VIT we have displayed in the first line. Now I need to, after displaying VIT in the first line, I need to come to the second line, okay, or second row. And here I need to show scope. Okay. So as I have completed the VIT transfer, now I need to come to the second line. That's why I use this particular command operation. Move P2 comma hash 0C0H a call command. And then we can transfer the scope. So you can see move P2 as CO PE, and every time when we are transferring the data, we need to use a call data operation, because every time when you are transferring the data, you need to come to this subroutine data subroutine part. The way you have done for command operation. Every time you are doing some command operation, you came to this subroutine part. Here also you need to do the same thing. And after coming to the scope means SEOPE at the end, you have to do short jump where you need to do back. You have to come to the back level. Where the back level? This is the back level. Why we are using this type of iteration? Because we need to continuously get the output of BIT scope in every iteration. Okay, now how to run this program in the previous, I think uh, 2-3 weeks before I have uploaded one video. And there I shown how to run the code in Keil software. This is a Keil software where I have written the code, this assembly language code. So you can follow that one to run the code. And after that, along with that one in that video, whatever procedure I have shown, same procedure only you need to follow with only one modification, because whatever the data we want to see, that for that only we need to use another software. So that is known as Proteus software. So what you need to do in Proteus software, whatever the code you are writing here, that hex file you need to give to the Proteus software. So for that you need to generate the hex file. So in order to generate the hex file, what change you need to do? You have to come to this project option. In that presentation also, I told what steps you need to follow in the presentation. In the project option, what you used to do, options for target one. There, what you used to do, what I told in that video, you had to just change the target option by this value 11.0592. You used to do this operation. Along with that one, you need to do another thing. You need to click on output. You need to click here. You need to select this one, create hex file. So this hex file will be run in the Proteus software to show the output. OK. So that's why I tick this one so that I can create the hex file, and I clicked on OK. OK. Now, whatever operation you want, this following thing you can, the remaining thing you can follow from the previous video, whatever I have uploaded that time. Now your hex file is created. Now what you need to do, you have to come to Proteus. So in the Proteus, you need to run this hex file. So how to do that? You open the Proteus. Okay, this is a very simple software. The procedure is very simple. What you need to do, you have to come to this file, new project, and to click on new project, and then you can select some folder to save your work. So suppose I am using my D drive to save my work. I can go to this particular software Proteus program. I've already created this folder. You can create one suitable folder, and inside that one I want to save my work. So suppose I'm creating another folder inside this one. I'm writing this name LCD new. Okay. So LCD new here. Now what I have to do, I need to click on next, 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 finish. Okay. Now in this software, what we are doing, because here we don't have the hardware to connect, so we'll get the platform to get the analogous form of the hardware. So how to do that? Suppose if you want to interface 8051 with LCD, then you need to select two component. One is 8051, another one is LCD. So how to select 8051? So you can here write down AT 89 C 51. Okay, this one you can select 89 C 51. This is nothing but a microcontroller. You have to select. Okay. Okay, click here, and along with that one, what you need to select? You need to select a LCD display. So you write down LCD. So out of this LCD, which one you need to use? You can use 16x2 alphanumeric LCD, that is LN016L. The number is this one. You can click on OK to select this one, and now click here. Okay, now your LCD came. So what we are doing in the program also, what we have done, similar type of things we need to do here. In the program, what we have written, we have connected port 2 with the different data lines of your LCD. So we'll do the same operation. You click here, each of the line you need to connect to this, each of the line of your display. So I'm connecting. I think. I'll zoom it first. Okay, now what you can do, we can connect this one. Okay, then the second line with the second port means second pin of that port. We can connect to the corresponding data lines here. So this software we are using basically to see the output. And this is the connection, this virtual type of connection we are making between the 8051 as well as between 8051 and LCD. Okay, so along with that, this is the data line connection I have done, and I considered port 1 pin number 0 as a this port number 1 pin 0, I have to connect with RS. Yeah, the program I have done like this way. If I'm not wrong, let me check. 0, I have connected with RS. Okay. So you take this one and connect it with RS. Okay. Then the second one, connect it with RW. And the third one, connect it with enable. Okay. Now, after that, what I need to do? I need to double click on 8051. Okay, here I need to select the frequency. That should be 11.0592 megahertz. And after that, we need to click on this folder. I need to select the hex file. So where is the hex file? I need to go to my Proteus. I need to go to this Keil's hex file. Actually, whatever hex file I created in the Keil, that I need to select. So you go to that one. Come to this object and you select this hex file. Open it. Okay. And click on OK. That's it. Okay. Now how to run? Here you need to click. So see, it is showing the 80 scope. Okay. And how to stop this running of this operation? You can click this icon to stop. Okay. Now here, one thing I forgot to tell you. Here you can do some programming for the delay operation, because when you were using this E terminal, you have to make it 1 first and you need to do some delay and then you have to make it 0. So how to do the delay? So for the delay operation also I have written a subroutine. I have taken 255 in R1 register and R1 is I am reducing the value of R1 until it becomes 0. So this procedure I followed to make some delay. Okay. So this I forgot to tell you that time. Okay. So thank you very much.